So today we're going to dive into combining expressions with multiplication and division. And it's really important in order to get this topic to understand exponents. So we're going to dive into a little exponent refresher and then work through a few practice problems, and the rest should be a breeze. So exponents, anytime I teach my students exponents, I always remind them that math is just another language. And just like you text your friends different shortcuts, you know, mathematicians have shortcuts in math to make things much more easier to write down, much more easier to communicate, and exponents are really a perfect example of that. I always think of them as the LOL of math. So when we have 2 to the 3rd power, what does that actually mean? It means 2 times 2 times 2. Now luckily that one you didn't have to write out a lot, but if I said 2 to the 11th, you would be like, all right, 2 times 2 times 2 times 2 times 2. That's extremely long to write. We can write it all out, but it's not as compact. And so mathematicians basically came up with this exponent format to make repeated multiplication so much more compact and easier to write. And so it's really no different when you have variables. X to the 3rd really just means x times x times x. So what happens when we have x to the 3rd multiplied by x squared? Well, we can actually break this out and see what happens. X to the 3rd is x times x times x, and x squared is just x times x. And we're putting those together by multiplying. Okay, wait a minute. I can actually write this another way, right? This is the same as saying x to the 5th, right? What are we doing? We're really just multiplying x by itself 5 times. And so there's a rule, an easier way to do this instead of breaking this all out each and every time you're encountering multiplication with the same base. All you have to do is really add your exponents. What do I mean by that? So x to the 3rd times x squared, we already know is x to the 5th. But what you can actually do is just add your exponents. So we keep the base the same, and I'm gonna get x to the power 3 plus 2. I'm adding those exponents. And that's the same as saying x to the 5th. So that's the rule. When you're multiplying exponents with the same base, all you have to do is add your exponents. But I really wanted you guys to understand why the rule exists, and so that if you ever get stumped or forget the rule, you can actually break things out for yourself. Okay, let's move on to dividing. So if we have 5 to the 4th over 5 squared, remember the fraction sign is also a division sign, so it's the same as saying 5 to the 4th divided by 5 squared. Let's break it out. Let's see what happens. 5 to the 4th, and the numerator is the same as 5 times 5 times 5 times 5, and 5 squared is just 5 times 5. Now, if you are familiar with fractions, you know the 5 and the 5 cross out, and the 5 and the 5 cross out, because 5 over 5 is just 1, right? So we have 1 times 1, and then we have 5 over 1 and 5 over 1, right? And so what do we get? We get 5 squared in the numerator, right? And so if you kind of caught on to the rule from the last, when we're multiplying, we add. When we're dividing, we actually subtract the exponents. So 5 to the 4th over 5 squared is the same as saying 5 to the power 4 minus 2, which is just 5 squared. And it's really no different when you have an exponent, right? Or a variable, I should say. What do we have here? We have x to the 4th over x squared is the same as x times x times x times x over x times x. We're gonna cross out our pairs of x's, and we're just left with x squared. So when you're dividing exponents with the same base, a really quick way to remember this is just subtract your exponents, right? Okay, so let's take a look at some practice problems to get a hang of this. So here we have 3a squared times 2a. So just like in the last lesson, we're gonna take those two coefficients, the 3 and the 2, and we're gonna multiply them together in this case. So we get 3 times 2 is 6. And now I have a squared times a. Remember, when you have a by itself or x by itself, you can also write that with an exponent of 1, right? So a is the same as a to the 1st power. So in this case, I'm like, wait, I have the same base being multiplied. All I have to do is add my exponents. So a squared times a gives me a to the 3rd. And so my answer is 6a to the 3rd. All right, let's look at the second one. So now we have 3a squared times 2b. What did I do? I changed that second variable. So how does my answer change? Well, in this case, we can't put the a squared and the b together. They have a different base. One has a base of a, one has a base of b. We can't put them together. But we can put the 3 and the 2 together. So what we get is 3 times 2 is 6, a squared b. Okay, what happens if we have these parentheses? Remember, there's different ways of writing multiplication. We can actually have the little dot, or we can have these parentheses, which also mean multiplying. So 5x times 2y is the same as 10xy. I can't put the x and the y together, right? I'm just going to leave them as being multiplied. Okay, let's take a look at a slightly challenging one. 9ab times 2a squared. Okay, so the 9 and the 2, I'm going to multiply, I'm going to get an 18. Then I get a times a squared, and I'm like, okay, a times a squared, I know from the first problem is a to the third, right? It's just like saying a to the first times a squared. I'm going to add my exponents. And then I'm just left with that b. So I get 18a cubed b. Let's move on to division. So let's take a look at the first one here. We have 10a over 5. Well, I can rewrite this as 10 over 5 times a over 1, right? I could always write this as 10 over 5 times a over 1. If you actually multiply your numerator and denominator, you start with what you got, right? And I do this because it helps me actually break this problem up. So I know 10 over 5, or 10 divided by 5, is just 2. And a over 1 is just a. And so my answer is 2a. What about this one? We have a squared over a. Remember that a is just a to the first power. Whenever you don't have a power, the power is 1. And I'm like, okay, now I have the same base and basically dividing. So I know the rule. If I have the same base and I'm dividing, I have to subtract the exponent. So I get a to the power 2 minus 1, which is just a to the first power, or just a. Okay, let's look at this one. We have 6a to the fourth over 3a squared. Okay, so I'm gonna actually put my 6 divided by 3, kind of taking the numbers so I know to divide them. And I'll put my a's over each other. So 6 over 3 times a to the fourth over a squared. So 6 over 3 is the same as 2. And a to the fourth divided by a squared is a to the 4 minus 2 power, which is just a to the a squared power. Okay, so that's really it for this lesson. I think the most important part is to remember your rules for exponents and how you work when you're multiplying and dividing. We're gonna jump into the practice set. The practice set has some really challenging ones, so don't skip it, and I will see you in the next lesson. Bye, guys.